Welcome to this video lecture on organic quantitative and synthesis in the second year, third semester of MSc Chemistry course. The first experiment we are going to see here is about estimation of phenol. We all know phenol is an aromatic alcohol and it undergoes electrophilic substitution reactions at ortho and para positions because it is an ortho and para director. This concept is considered here to estimate the phenol. So let us now go on to the experiment. The aim of the experiment is to estimate the amount of phenol present in the whole of the given solution. The principle is phenol is readily brominated by a known excess of acidified bromide-bromate mixture to give 2,4,6-tribromo-phenol, that is in the ortho and para positions. The excess unreacted bromine liberates iodine from potassium iodide, and the liberated iodine is titrated against sodium thiosulfate solution. From the quantity of bromine consumed, the amount of phenol present is calculated. For bromination, the bromide-bromate solution is preferred instead of bromine because the latter, that is the bromine, loses its strength on keeping due to volatility of bromine. Since 1 mole of phenol consumes 6 equivalents of bromine, the equivalent mass of phenol is 1/6 of its molecular mass. Let us see the equations now. Bromate-bromide mixture is nothing but potassium bromate and potassium bromide, and in the presence of hydrochloric acid it liberates bromine. So that is the first chemical equation given here. Mixture of potassium bromate and potassium bromide is what we call it as a bromate-bromide mixture, that with 6 molecules of hydrochloric acid will give 3 molecules of bromine and plus potassium chloride and water. Now when this liberated bromine reacts with a phenol, that is our aromatic alcohol, it gives 2,4,6-tribromo-phenol, which is an yellow color compound, and 3 molecules of hydrogen bromide. Now 1 molecule of phenol reacts with 3 molecules of bromine to give 1 molecule of 2,4,6-tribromo-phenol and 3 molecules of hydrogen bromide. So if we have to calculate the equivalent mass of phenol, we need to divide the molecular mass of phenol by 6 because it reacts with 6 equivalent atoms of bromine. It reacts with 3 molecules of bromine, which means it is 6 equivalent bromine atoms. So that gives 15.67 grams. Hence the equivalent mass of phenol is 15.67 grams. Now we will go on to the procedure. First we need to prepare the brominating solution. So as we said earlier, the brominating solution or the mixture is prepared by mixing potassium bromide and potassium bromate. So this is taken in 15 grams of potassium bromide and 2.78 grams of potassium bromate for 1 liter. So this both is mixed up and made up to 1 liter using water. This solution is also called as Winkler's solution. Now next we have to do the solution standardization, that is sodium thiosulfate standardization. For standardization we need to have a primary standard, which is nothing but potassium dichromate, and this should be is about 0.1 N strength. So for this reason we are approximately taking 1.25 grams, which we have to note down the weight of how much we are weighing and transferring it into the 250 ml standard flask to prepare 0.1 N potassium dichromate. So using this primary standard solution, we are going to standardize the thiosulfate solution. So the procedure is like 20 ml of the potassium dichromate solution is prepared out in the clean conical flask. Then add dilute sulfuric acid solution and potassium iodide 10% of 20 ml, and then the liberated iodine is titrated against the thio solution using starch as an indicator. The starch should be a fresh solution. So from the two consecutive concordant titer values, the strength of the thio solution can be determined because we already know the strength of the potassium dichromate solution. The next we need to standardize the brominating mixture. So this is done by taking 20 ml of the prepared brominating mixture into a stoppered conical flask, and to this solution 5 ml of the concentrated hydrochloric acid and 20 ml of potassium iodide is titrated against the standard thio solution using starch as an indicator. So from the titer values, the amount of thiosulfate solution required for this 20 ml of the brominating mixture can be calculated. Now after standardizing the thiosulfate solution, and the brominating mixture. Let us now come to the estimation of phenol. So the given phenol solution is made up to 100 ml in a standard flask, and from this 20 ml of the solution is prepared into a clean stoppered conical flask. So to this solution of phenol, 5 ml of concentrated hydrochloric acid and 50 ml of distilled water are added, and it is stoppered. The brominating solution is then run in from a burette to this conical flask with constant shaking till a permanent yellow color is produced. So this permanent yellow color produces nothing but the indication of the product 2,4,6-tribromo-phenol. So the volume of the brominating mixture added is also noted down. Then about 20 ml of 10% potassium iodide solution is added, and the liberated iodine is titrated against the standard thiosulfate solution using starch as an indicator. So that titration is repeated to get concordant values, and from the titer values the strength of phenol solution and hence its amount is calculated. So now first what we are going to do is calculate the amount of sodium thiosulfate solution used for 20 ml of the brominating mixture, then the sodium thiosulfate solution consumed for the excess of bromate mixture after the consumption of a phenol will be calculated, and by this we can find out the amount of a phenol present in the given solution. Here the tabulation and calculation involved in the estimation of phenol is given. So this will be written in the left side of your observation notebook. First, standardization of thio solution. For this we need to know the strength of the potassium dichromate. So the weight of the potassium dichromate used in making up the solution is noted down, and from this the strength of the standard potassium dichromate solution is found out. And titration of potassium dichromate with the sodium thiosulfate solution will help us to know the strength of the sodium thiosulfate solution, that is nothing but the standardizing the sodium thiosulfate solution. In this slide we are seeing two more tabular columns with respect to the bromate mixture. The first one is the standardization of the brominating mixture, that is the potassium bromide and bromate, where we are taking 20 ml of the Winkler solution and titrating with the sodium thiosulfate solution. So the volume of sodium thiosulfate solution consumed for the 20 ml of bromate mixture can be known, and from this the volume of sodium thiosulfate solution consumed for 1 ml of bromate mixture also can be found out. The second one is the estimation of phenol in this slide, and in this estimation tabular column we can see the volume of the Winkler solution, that is the excess amount which has been added has already been noted down. If it is a 5 ml, approximately if it is 5 ml, so the excess of 5 ml added to the solution is also noted down, and that will give to 25 ml on the whole. And this Winkler solution in phenol will be titrated against sodium thiosulfate solution. The values found at the end point is also noted down here. After noting down the titrant values during the titration, we need to calculate the amount of phenol present in the given solution. So for this reason we need to know the volume of thiosulfate solution that is required for the consumption of excess of a brominating mixture present in the solution of a phenol and the bromate mixture. And later we need to calculate the volume of thiosulfate solution, which is equivalent to the amount of phenol present in the solution. And from these values we will know the strength of the phenol. So after knowing the strength of the phenol, the amount of the phenol present in the given solution can be calculated using the equivalent weight of the phenol. Since we already know equivalent weight of phenol is 15.67, the strength of the solution into 15.67 divided by 10 will give us the amount of phenol present in the given solution, and that is represented here as W grams. After finding out the amount of phenol present in the given solution, the result is written as the amount of phenol present in the whole of the given solution is equal to W grams. So this W is the calculated value from the titer values we obtained. Thank you all.